let's look at the next one. It says 97% of 73.6 is what? So this is where I'm going to change it to a decimal first. How do I change 97% to a decimal? It moves it over 2 places. If I divide by 100, I get 0.97. Remember, the word of meant multiplication. Then I have the number 73.6. Remember, the word is means equals. And then I have what? I'm going to put an X there. So for this one, it's actually set up exactly the way I need it to be. I'm going to take the 0.97 and multiply by the 73.6. What do I get there? Before I round, I get 71.392. I want to round to 1 decimal place, which means I need to look at this one. That 9 tells me to round up. So my final answer here is 71.4. For these, you are finding the percent change. Again, they want it to the nearest 1/10 of a percent. So we're going to find our decimal first, and then we are going to multiply by 100, and then we're going to round to 1 decimal place. All right? Remember with these, your numerator is just what happens when you subtract the 2, absolute value. You don't need positives or negatives here. And then the denominator is always my first initial number. All right? Not just my biggest one, but just my first one. So in this case, the first thing I need to find is the numerator. You can subtract any direction. So I can just say 50 minus 36.8. What do I do when I get that for my numerator? What's my numerator going to be there? 13.2. So then what is my denominator? So the most common mistake is to pick the larger number. Go back to your original problem. The first number was 36.8, so we're going to put 36.8 right there. So in your calculators, you're going to take 13.2. You're going to divide by 36.8. 13.2 divided by 36.8. All right, so when we divide, we are going to get 0.35869, and it just keeps going, right? You need to multiply that number by 100. Multiply that number by 100. All right. And then you're going to get 35.869, and it keeps going. All right. It wants it to the nearest 1/10 of a percent. All right. We're already in percent, but we need to round to the nearest 1/10 of a percent. So I need to look at that 8. That's the one I'm rounding. So I look to the number next to it. It's 5 or above. That 8's going to go up. So my final answer here is 35.9%. There's one more thing you need to tell me. Did it increase or decrease? Well, it went from 36.8 to 50. Is that an increase or a decrease? That is an increase. So your answer is 35.9% increase. I need both of those pieces. All right, so let's look at the next one. The next one goes from 19 to 16. My numerator is just going to be that 19 minus that 16. So what is my numerator going to be? 3. What is my denominator? My denominator is the first number, so it is 19. All right, so I'm going to say 3 divided by 19 and multiply by 100. You should get approximately 15.7894, right? All right, so now to round, I'm going to look at the 7 is the place that I want to round. I'm going to look to the right of it. It is an 8. So I'm going to round that 7 up. It's going to be 15.8%. Was this an increase or a decrease? We went from 19 to 16. That is a decrease. So it is 15.8% decrease. 15.8% decrease is my entire answer. This one says Tim is running laps on a track. He finishes the first lap in 40 seconds. For the second lap, he manages to finish in 36 seconds. What percent of his time was he able to shave off from lap 1 to lap 2? All right. So the first thing I'm going to do is find out my numerator. My numerator is just the subtraction of those. The subtraction of those would be 40 minus 36. All right. So what's my numerator here? It is 4. Divided by my initial number. What was the first number we talked about? 40. You're going to take 40 divided by 40, multiply by 100, and you should get 10% decrease in his time. We moved from just percent increase, decrease to problems where you pay markups or where you have discounts. All of those are basically multiplying by a set amount multiplied by a percent change and then a new amount. So you could be given the new amount with the percent. You could be given the original amount with the percent, or you could be given the original and the new and they want the percent, right? So it's the same concept. Your original times your percent plus 1, remember, is going to equal your new, or you can multiply and find the increase and add it or subtract it, depending on whether it's an increase or a decrease. This says Sarah wants to buy a new pair of shoes that are priced at $50. The store offers a 20% discount on all shoes. What will the sale price of the shoes be after the discount is applied? All right, there's 2 ways to do this. The first way is just to find the discount and subtract it. How would I find the discount? What would I do? I would take what? So if I just wanted to find the discount amount would be the $50 times the 20%, right? Which would give me what? $10. She did not pay $10. That is not the sale price. That's how much they took off. So you would have to start with that 50 and subtract the 10 to get how much she paid for it, which would be $40. All right. The other way to do this is to multiply the original price by what the percent that she paid. Okay. So if you wanted to go straight to the sale price, if she took 20% off, what percent did she pay? If they took 20% off, she paid what percent? 80%. So the other way to do this is to go straight to 50 times 80 and you will get the 40 and you don't have to subtract anything. Either way, you get the same number, okay? You can just find the discount and subtract it, or you can just multiply it by what percent you paid of it. Either way, you're going to get that $40. Let's look at number 32 on the next page. Jennifer works at a jewelry store and earned a base pay of $12 per hour. Last week, she worked 40 hours. She also earned 12% commission on the total sales of the store, which was $8,000. What is her gross pay for the week? All right. So she got $12 an hour and worked 40 hours. How do we figure out that piece of her pay? Just multiply $12 an hour times 40 hours. That's not all she got. In addition to that, she earned 12% of the sales. How do we calculate what she earned off the sales? So we're going to say that $8,000 in sales times what? 0.12. That total should give us what she earned, right? So if we do the 12 times the 40, what do we get here? Right, so we get basically $480 because it's just 4 times 12 with that 0. All right, how much did she earn from the $8,000? So this piece of it is going to be $960. If we add those two together, what was her total pay? $1,440. And that is her pay. Also did percent error and percent difference. Percent error and percent difference. For percent error, your numerator is going to be the absolute value of your experiment minus your known. And your denominator is always going to be your known, right? And of course, to get percent, we would multiply by 100. All right, for percent difference, you do the first one. So your first trial minus your second trial. That's still your numerator. But your denominator for this one is your average, right? So the denominator for this one is going to be your average of the two. So you would take your first and your second and add them and divide by 2, right? So that is your average. So if this is percent error, this one is percent difference. All right, percent error, you're going to have a known amount. Percent difference, you're going to have 2 amounts that you try. Okay? And so the denominator on the known amount is that known amount. The denominator on the 2 differences is you are going to do the average. Just if you were averaging any 2 numbers, add and divide by 2. That's your denominator there. All right? So for this one, it says percent error. Percent error. So a student measured the length of the table to be 180. The actual length is 220. Calculate the percent error. So I'm going to say 180 minus 220 is my numerator, absolute value, because I don't need a negative or positive here. What is my known value that will be my denominator here? What's my known value? The 220. All right. So what is the absolute value of 180 minus 220? It's 40. And what happens when I divide 40 by 220 and then multiply by 100? What do I get there? For all of these, I also want you to round to the nearest, like that, right? So round to the nearest tenth. So I'm going to look here. So that's 18.2% error. That is her error rate.